Hello, this is Professor Biswite. Today we will learn how to solve 3D systems of equations using a method called matrix method. Okay, let's get started. The first thing you do is you need to write all your three equations. We are talking about linear equations in this form: x, y, and z on the left, the constant on the right. So you're going to end up having a system like this. Now, the next thing you're going to have, you're going to write down the augmented matrix. Augmented means increased. And I'll show you how that works. A matrix looks like this. And since it's augmented, that means it's increased. You're going to put a line right here. And this is how you're going to write. These are all the coefficients: A, B, C, E, F, G, J, K, L, and then on the right you have D, H, and M, the constants. All right? So it's pretty easy. Make sure you order them. This is the X, this is the Y, and this is the Z. It's just a procedure, and this is the constant. All right. So the first thing you do. All right. This is what you do. Use row transformations to rewrite the augmented matrix in triangular form, ones on diagonals and zeros underneath. So you end up, this was what you started with. A, B, C, and you have D, H, M, and then you had E, F, G, and you have J, K, L. All right? You're going to do a bunch of things to it, row transformations, and I'll be specific about what you need to do. And you're going to put this matrix in this form. You're going to have a triangular matrix, which is going to have ones at the diagonal and zeros at the bottom. It doesn't matter what you have in here. All right? It doesn't matter what you have in here. But what that means is this row is going to give you the z. This is like 0 times x plus 0 times y plus 1 times z equals that. So this is going to give you the z. You're going to substitute back, and you're going to get the y from here. And now you have y and z, and you substitute back, you're going to get the x from here. Very powerful method. So you solve for the third row, go back to second row, go back to first row, and it works like a charm. I'll show you. Now, what are those row transformations that we're talking about? So you're allowed a couple of things, and make sure you understand that. All numbers in a row can be multiplied or divided by a non-zero number. Okay? Why do you do that? You do that so that you can eliminate certain things. The rows can be added or subtracted from each other. And you can also switch them. You have one row and then you move it to third and then second to first and so on. So these are the row transformations that you're allowed with. Well, let's look at it. Let's talk about the augmented matrix that I have here. So I'm going to write it down first. This is what you have: -3, 5, 10. You have 2x, not x, 2, -1, 4, 1, 0, -4, and you have 6, -1, and 2. Does it make sense? Okay. Now, what I'm going to do, I'm going to write down what I have, and now you're going to see. So the first one says, let's do it this way so you can see it. Interchange the first two rows. Okay, interchange the first two rows. This is what I have. So the second row will go to top, and the top will go to the second. 1, 0, -4, and 5. Then you have 2, -1, and 4, and -3. And I didn't touch the third one. Okay? Now guess what? Now I have the 1 on top. So that is the first one you do. First, get 1 on the left upper corner. That's the first one. So I was successful in doing that. Second thing is I want to get rid of that. Now, get 0 on the first column of second row. So this one is the one that I want to get rid of. So what can I do? So if this is my 1, 2, and 3, what I can do is write the first as is. But what I'm going to do, I'm going to take the 2, and I'm going to take the first row, multiply it by -2, and add it to existing second row, and put that in second row. All right, what does that do? 1 times -2 plus 2, that's 0. 1 time, so 0 times -2, that's 0, plus that, that's -1. And this one is -2 times -4, that's +8, plus 4, 12. This one, -2 times -5, -2 times 5, that's -10, minus 3, -13. So let me make sure. This one is 0. This one is -1. That's 12. That's -13. Now, what I'm going to do, this is the same. All right? The next thing you do, let me put that in here so that you see it. Multiply the first row. Now these are the new numbering system. This is number 1, this is number 2, this is number 3. Multiply the first row by -6 and add it to the third row. Does it make sense? So what happens is I have the first one as is. I didn't change. Second one as is. I did not change. Now what I'm going to do is I'm going to take this one, multiply by -6, and add it to here. So this is going to be, I'm going to take the first row, which is 1, multiply with -6, and add it to third row, and put that into the new third row. Okay? So what that's going to do is this plus that, -6 plus 6, that's 0. -6 times 0 is 0, plus this is -1. And this one is -6 times -4, that's 24, plus 2, 26. This one is -6 times -5, -30, plus 10, -20. Does it make sense? All right. Now, multiply the second row by -1. So I do nothing to the first. Hopefully I didn't make any mistake. Second row by -1, so that's going to be this. And this is what I got. All right. And we're getting there. Actually, I don't need to do that. I already did that. So what I need to do, add, yeah, this is okay. The multiply -1 second row, I did that. So add second row to third row at this point. So this into here. 1, 0, -4. This one is 0, 1, -12. And now let's add the second to third. Here's a 0. Here's a 0. This one is going to give me 14. And this one is going to give me negative 7. Okay, very good. Now I'm going to solve for z. Watch. From here, I'll get 14z equals negative 7. Z equals negative 7 over 14, which is negative 1/2. Okay, I got that. Now that I have negative 1/2, I'm going to go back to this equation, this one. Let me do everything in here so that you can see it. This one gave me this. Solve for z. So I did that. Now I'll solve for y. So that's going to come from here. That's going to be 1y minus 12z equals 13. Y minus 12, and z I got negative 1/2 equals 13. So this is y plus 6 equals 13. That gives me y equals 7. Okay? Now let's solve for x. So let's go use the first row. 1x plus 0y minus 4z equals 5. So x minus 4, what was z? Negative 1/2. So what's that mean? X plus, this one is 2. So x equals 3. So what I end up having? I have solution x3, y7, and z negative 1/2. Does it make sense? All right. Now let's look at a couple of things. What happens when I have an inconsistent dependent system and I'm doing it with this method? Okay. When I do all my eliminations at the end, at some point I'm going to end up with something 0 times z equals 5 or something that doesn't make any sense. You'll end up with a contradiction. Okay? And then that's going to tell you that you had an inconsistent system and you have no solution for it. Now, sometimes you'll end up with a dependent system, and you're going to have it with the too many zeros, like your entire row is going to be something like that. Okay? With the augmented matrix, we're like, what is that supposed to mean? I don't have anything. So, too many zeros. So that means dependent system, you have, two planes that are disguised as each other or on top of each other, something like that. So you have infinitely many solutions, and you have a dependent system. Okay, it might be the whole plane that's your solution. It may be 3 planes on top of each other, maybe something like that. So you can see the dependent system. You're going to see very, very clearly that you'll have like 0 equals 0 or 0 equals 5. You're going to either end up with a contradiction or 0 equals 0, something like that. So you can just say this is an inconsistent or dependent system.